I think what I want to start with is I'm going to go over the ideas in each chapter with you guys just to see if it kind of dredges up some memories and some concerns. Hey! Something happening? What's up?
Yeah.
You can get everything. Hold on.
Okay, great. And Amy wasn't feeling like she did either, and she wanted to get a treat for her too. Sorry about that.
This is an art eraser, isn't it?
The what?
This is an art eraser?
Yes. So from close tattoo.
Yeah, that's how mine is.
All right. Pay attention to that.
Okay,
Yeah, I have all these.
Perfect. I'll see you then.
Okay, thank you.
Thank you.
Number 2 pencils.
All right, guys, so real quick, first thing I want to say, I think I said this last time. When does the final exam start? Next Thursday. Anybody, when's the final exam start next Thursday?
11:35 a.m.
Yeah. And when does our class normally start?
12:30.
12:30. All right. So, if you show up at 12:30 next Thursday, you have chosen an hour for the final, and that's something you can do. That's your choice, right? So if you want to show up late, have less time for the final, that's your choice, right? So if you want the full time, get here at 11:35. I'll be in here in the classroom. You can see from 10:30 to 11:30. Right? So I'll be here.
Did I find out? Just the fine or practice. But then next Tuesday is what's
Professor, do you have any extra
Oh yeah,
practice
it's
tests?
FPV
Yeah.
Live because I did the test correction, so now.
Is it okay if I use my phone as a calculator?
So I think after I do these corrections.
Use your phone as a calculator. During the final?
Oh no, like right now for the practice.
Oh, right now. Oh, I don't understand. There's nothing you have to work on right now.
Oh.
Yeah. So you can use your phone for whatever the hell you want to. Yeah, guys, so just like the previous test review days, I know that this test we're talking about today is the final. I understand that, and it always causes people stress. One thing I want to let you know, and this will, depending on where you are now, grade-wise, this might cause you a little more stress, but how much is the final exam worth here? Do you guys remember? I'm not asking because I don't know. I'm asking just to see if you know. It's like a something or something, right? You guys remember?
20 or 25.
20 or 25, right? 20 or 25. So tell me, real quick, tell me this. How much of your grade is set before you take the final? About 80 to 75%, 75 to 80%, yes? So for those of you who are with a passing grade right now, or a B or an A or whatever, understand that the final is 1/3 or 1/4 the weight of what you're coming in with. Do you understand? So I'm hoping that on my grade sheet summary where I show you what you need to make on the final to do various things, that kind of makes you realize the final can't hurt you as much as you sort of build it up in your head. Now, is the final worth more than any test? Yes. Is the final worth more than quizzes? Hell yeah. Is the final worth anywhere near as much as everything you've done so far put together? No. It's like 1/3 or 1/4, right? Now, still, can it affect you? Of course, but not as much as we sometimes build up. Now, the sucky part about what I just said is if you are in a position you don't want to be in, the final can only save you so much, right? But still, if you do really well in the final, you never know. See what happens. Okay, so everybody understands. Next Thursday, we do start earlier than normal, right? I will be in here starting at 10:30. If you want to come in early with some last minute questions, fantastic. I'm going to bring some food, right? I know, right? For me, I'm gonna eat it. You can watch. No, I'm gonna share it with you guys. I'll share some with you guys. Yeah. Okay. So, if there's no other specific questions at the moment, I kind of want to go through all the chapters. Right? We're gonna do an insane thing right now. We're gonna do the entire semester in about 5 minutes. Right? Holy shit. Well, we'll see if I don't know. I didn't really time myself on this. And you guys are gonna help me. You guys are gonna help me a little bit. Because I don't know if you picked up on the fact that I'm a little absent-minded, which is really great. So let's see if I can remember everything. So we actually started the semester off with chapter 2, right? I held on to chapter 1 because it was like dessert, word problems. Oh yes. Chapter 2, just to give you a little hint, it was about sets, right? And what goes along with sets? What kind of ideas, what kind of calculations, or what kind of things that we have to do with sets?
The intersection?
Intersection, union. Does this sound familiar? The or and the and? Yes? Yes? Okay. Intersection, sort of like that first problem, I think, on the practice final. So that's sets, right? And then there was different number systems. So what does that mean, different number systems? Give me an example.
Bases.
Yeah, like, okay, good, the different bases. Let me put that up here. So there's different bases. So that's like staying in our number system, but just pretending like we had 8 fingers, so we have base 8 or something, right?
Yeah.
But what's different number systems mean? Babylonian.
Chinese.
Yeah, the Chinese we talked about a little bit. Mayan, Roman, Egyptian, right? And of course there's multitudes others that we just didn't look at. But they're out there. I liked it. So again, just so you know, if you look back at test 1, I will give you the exact same information about them that I gave you then. Like the Mayan base, I'll give you the Roman numerals, I'll give you the Egyptian numerals, right? Okay. Blah, blah, blah. And of course, do you guys remember what our system is called officially?
Decimal?
Hmm?
Decimal?
No?
Or under like the Arabic?
Yeah, Hindu Arabic. I love it. So we have a Hindu Arabic system. That's where it came from. We didn't create it ourselves. We just kind of stole it, right? Something we're really good at with numbers and words. We like to steal them from other people. So we have a Hindu Arabic number system. So we did chapter 2. We started off there because it's kind of cool. Everybody, I kind of like the pancakes and blueberries and stuff, so I thought that was a good place to start. Then we kind of came back and said, now that you're all in the course and you're starting here, let's go back and look at freaking word problems, right? So this is officially called problem-solving strategies. Does anyone remember any of those strategies?
Drawing a picture.
Drawing a picture,
Solving
Making
a
a list. Making a list.
make a list, solve a simpler problem, guess and check, or like the book says, guess and test, which is not nearly as interesting. And then there's a couple others, who cares? But that's the idea with chapter 1, was just, here's some word problems, can you put this stuff together correctly, right? Then we got into chapter 3. This one is kind of packed with stuff. We got into whole number, addition, subtraction, inequalities, so there's a whole lot of stuff. There's whole number, adding, subtracting, properties. Remember, like closure, commutativity, associativity, distributivity. Subtraction real quick. All right, let me get this started a little bit. With subtraction, you've got the takeaway method. Does anyone remember a different method? So subtraction, there's the takeaway method.
The missing added.
Good, missing addend. And then there was one that was sort of on the book, and it was sort of like, it's called comparison. That was just a type of problem. Right, so if he said Sam had 7 books and he lost 3, that's not a comparison. If he said Sam has 7 books and Josie has 3 books, how many more? That's comparison.
Yeah.
Okay. I don't know if this is helpful, but I just want to kind of throw up here all the ideas from the semester, and then we can kind of start to pick them apart. I'm not going to get too specific because that would take us forever. Multiplication, division. Of course, you have missing factor. That's a lot like the missing addend, right? What else do you have? Share versus measure. How to break things up. You can either break them into groups, or you have groups established and you figure out how much each group gets. That's the share versus measure. Missing factor. Repeated subtraction, because of course multiplication is repeated addition, so division is repeated subtraction. I love it. Then chapter 4. This was the mental math. This is like, how do you add, subtract stuff in your head? Does anyone remember any strategies from that? There were the 2 C's. When I want to add 2 numbers.
Complementary.
Yeah, compatible. I'm with you. So like compatible, like 6 plus 4, right? Then there's another C. Shit, did I do that?
Was it, was it crap?
What a day to learn I have telekinesis. I'm so sorry. No, I'm good.
I'm glad it kicked in.
I'm a paper bender.
Have you seen that, the paper? I'll tell you about it.
All right. So
Remind me
guys,
about the paper.
so we have compatible numbers, and then we have compensation, right? Compensation.
Oh, yeah.
I like it. Let's see, special factors. This is where we did the, chapter 3, let's see, chapter 2, we actually brought out the flats and the longs and the units. All right. Then 5, let's see, so 4, how do I summarize 4? It's just mental math. Chapter 5 was primes, divisibility rules, right?
Oh, yeah.
How to tell if something's divisible by 2, 3, 4, all that kind of stuff. Yeah. This is where we did GCF, LCM, so we got primes, we got divisibility stuff. We've got, where to go? How to count how many factors something's gonna have, GCF, LCM, all that kind of stuff. That's all in there. I like it. And then chapter 6, we get into fractions. Everybody was like, finally. Wait for it. I love this shit. We have region models, which we used in many, many different ways. We've got how to order fractions, how to find lowest common denominator, mixed numbers, all this stuff with fractions. Anything else? Yeah. Then, of course, we had decimals, the connection to fractions, relation to fractions. Man, I'm writing really well today. The places for decimals, tenths, hundredths, thousandths, right? All the lift-y things. Anything else special there? Ratio and proportion, percentages, right? All that stuff was in chapter 7. Ratios, percentages, blah, blah, blah. Oh boy. And then more recently we got in chapter 8, integers. We finally were allowed to work directly with negative things, right? Which, if you're like me, your bank sometimes works for those. Not anymore, thankfully. That was my, yeah. You got set model. Remember we had like the red and the black, the negative and positive, that kind of thing. And then of course we use the set model to look at adding, subtracting, even multiplying, dividing. Yeah. And then, of course, the last thing, the only thing we did in chapter 9 was 9.2. 9.1 is extra credit, in case you didn't hear that. 9.1 is extra credit. And 9.2 is really about irrational numbers, roots, and then solving equations, right? Irrationals, roots, and solving equations. All right. Good. Good job there, Jeff. I don't know. Sometimes I feel like I'm writing in Babylonian. All right, that's a lot. We did quite a bit this semester. And hopefully everything kind of, now there's a lot of details surrounding these, but these are kind of like the main ideas. So I just wanted to get that up there. And now it's up to you guys. Do you have any specific thing you want to look at? Either from the practice test or the practice final or the homework? Or just,
Practice final on number 3C, the little line on top of the B, does that mean everything that's not in B?
yes, good.
So,
Now, that would be totally unfair of a question if I didn't also tell you which thing.
Yeah, you,
Good, that's the whole universe. So everything's not in B means everything that's in the universe that's not in B.
okay,
Yep.
and then the little, this one is or, and then this one is.
Yeah, I like to remember, you or you, somebody, I do this like, God, somebody, you or you, I don't care. You. And then the and looks like an A that lost its bar in the middle, right? So it looks like this.
Okay.
That's how now it's sort of, when I see the symbol, I read the word. But in the beginning, when I first learned them, that's how I kind of kept them apart. Yeah.
So for 3C, would it be okay to put things that are also in A, or only in the universe?
No. So okay. So 3C says, doesn't care about A at all. It just says, give me everything that's not in B. So can it be in A? Of course. Give me everything that's not in B. That's all it says. Yeah. Yes. Yeah. Does anyone else need a practice final? Sure.
Okay. And it's just what they share.
Yeah. So what's an A?
You guys all,
I have a question about the test. It's my last correction, but I don't know, like, I'm confused with what you said. Because on number 5, it asks for the mistake, but is there more than that, or is that just like one mistake?
oh, super coming over here. Okay. And of course, that's not their only mistake. Because what mistake did they make from here to here? When you multiply fractions, you're supposed to multiply.
The top and the bottom.
Yeah.
So for the first and second degree was this one,
Oh, I said that they found us on
So really, so on that problem you're talking about, you could say, well, Jeff, you said one mistake, but the mistake they made was they treated it as if it was an addition subtraction problem. And in addition subtraction, what do? Find an LCD, and that stays the same. That's basically what they did. They completely didn't realize multiplication division is different than, yeah. I like it. I can't remember if I said this when everybody who's here got here, but pay attention to the fact the final starts at 11, what was it?
35.
35? Glad I got it right down. We normally start class at 12:30, so you get here at 11:35. If you get here at 12:30, you get 1 hour for the final, right? If you get here at 1:31, you get 4 minutes for the final. Woo! That is a fair choice. If you have issues, I will be checking my email, right? If you have issues getting to the class.
I just had a specific question of this. I'm looking at my last corrections right now. So I was a little confused on this. This is letting me get on the final?
Yeah, you would need this on the final if you had no homework turned in to get that.
Okay.
But I mean, and that kind of makes sense since you're, you know,
Yeah,
it's
yeah,
kind of
yeah,
far away.
yeah.
But just to do this, you
Okay.
just need this.
Okay.
If you had no one, would yeah, so forth.
Okay.
Yeah.
I'm just going, what is the negatives mean?
Hey, the negative means that you would have to somehow get a negative grade on the final. Which I sometimes joke and say, you'd have to run me over on purpose twice. And thankfully, nobody's like, let me find out if that's true. Yeah,
Okay.
so, yeah.
Negative.
I mean, that, yeah, so what you're trying, so watch this. If anybody is in a situation where your goal is A minus or higher, if you look at what you need to pass, and then you look at what you need to make a B minus, do you see how much I added from pass to B minus? Does that make sense? So if I need like a 70 to pass, or let's make this better. If I need a 50 to pass, and then I need an 88 to get a B minus, that's 38 points. So then I'm gonna add another 38 points to see what I need for an A minus. Does that make sense?
Yeah.
So again, so this is, what does it mean to pass? Get a 70, right? What does it mean to get a B minus? Get an 80. What does it mean to get an A minus? Get a 90. So here, this is the average for everybody. So this person, let's pretend they have all the homework turned in. They need a 36.4 to pass. They need a 74.8 to get a B minus. So what do I need to get an A minus? Well, it's 38 points I added to get from pass to B minus. So I'm going to add that same amount to see what I need for an A minus. Now, if that's still not clear, you can always ask me after class. But yes.
Well, for number 6, you set it up like this, right? The 148.
Yeah. And just make sure. I mean, go one more place at least. What would the next place up be, right? Because you might not have gone far enough.
Yeah.
There gonna be a brownie problem in the final?
I mean, I could. Yeah, I might make one just for you. We'll see. Yeah.
How would you find the GCF using subtraction?
Oh. Yeah, we did a problem sort of like this. Let me see, I'm gonna use this board over here. So we discussed this one, I think, specifically last time. If I want to find the GCF, what was it, 540, 300?
Yeah.
If I want to find the GCF of those two, right? Some methods would take me forever to do. But what does it mean? All right, so for example, real quick. What is the GCF of 4 and 16?
4.
Why?
Because 4 goes into...
Beautiful. Here's an even better way to explain it, or a more generally useful way to think about it. 4 and 16 are both in the list of multiples of 4, yes? And how far apart is every multiple of 4 from each other? It's some multiple of 4, right? Aren't these 4 apart? Aren't these 8 apart? So if I subtract those two, they're still going to be related in the same way as they were. They're still going to be in the same list of multiples they would have been. I really want that to make sense. This is related to, I don't know if you guys remember, but I said, if you try to reduce a fraction, how far apart are those? 24. So either 24 goes into both, or some factor of 24 goes into both. Because they're all going to line up in some multiples list. I really want that to make sense. So really, that's what leads us to this. If I do 540 minus 300, I get 240. So this equals the GCF of 240 and 300. Then I do it again.
300 minus 40.
Yeah, and then every time I do it, I replace the bigger one with the new small answer I got. And it's guaranteed to still have the same answer because I've kept them on the same multiples list that they were. I don't know if that, I really want that to make sense, obviously. So then you do it again, you get 60, you do it again, you do it again. Yeah.
So, for example, that one, like, subtracting,
Oh, okay.
gets the 180 minus 60 equals 120.
Minus
Then-
60
that
is
would
60.
be-
So 60, 60, that's easy, right? The GCF of AA is A. Yeah, because that's, yeah. Biggest thing that goes into both is itself. I love it. So you can take the subtraction all the way down until you get the same number of both or something, and then you're golden. I like it.
Oh, yeah. 'Cause I did some on the homework, and I was like, I think it was the set B.
Oh,
I
every
was
cell.
like, no, this is the only way it's, this is where the rub goes, you know?
Yeah. All right. All right. So, oh, good.
I was gonna ask about the sharing versus measurement. 'Cause
Yes.
I'm still confused on that. So, is
All right.
measurement when you have the established groups that you gotta measure out into?
No,
or is it
sharing
different?
is, which
Okay.
makes sense. So if
Okay.
sharing would be, I have so many rows and I have so much stuff, and I just want to know how much does each row get,
Okay.
right?
Yeah.
Measurement is, I've got so much stuff, how many groups would I need to set up so that I could
Okay.
give each group the amount? Now, to be really honest, it's basically a 0% chance I'm going to ask you a question like, identify if this is sharing. I mean, to be really honest, because it almost doesn't matter what you call it, because both physical situations make sense. What's more interesting is the fact that they both lead to the same operation, right?
Mm-hmm.
Yeah.
So I have 80 tennis balls, and each court needs 10. It's like,
Yeah.
how many courts?
Oh, I see. Or I have 80 tennis balls and I want to put 10 on each court. How many courts can I use then? Yeah.
Alright, so that's
Versus I have 80 tennis balls and there's 10 courts.
Uh-huh.
How many tennis balls does each court get?
So my example is measurement. The other one's sharing.
Let me see what I remember.
I have 80 tennis balls.
Yeah, if you have established groups, that's sharing.
Okay.
If you don't have established groups, that's measurement.
Got it.
Yeah.
Okay, I got it.
All right. And again, I mean, even though you can barely read this, this is the kind of thing you should do for yourself, and it's not that difficult to do. And it's just nice to have this as you go through the practice final. You can kind of see where it falls. You can put a little check mark next to an idea if you feel pretty comfortable about it, right? Yes.
I'll look at it.
Is it the Mayan or Babylonian one we're supposed to remember?
Are you?
Oh,
Yeah.
Mayan symbols. You gotta remember. So, and Babylonian, you gotta remember everything about them. Everything. So what can you guys tell me about Babylonian numeral system, enumeration system? What do you tell me about the numerals? Oh, base
60.
60. I like it. So 1, 60, 3600, so forth. And how many symbols for numerals did they use? 2. I like it. What were they?
The weird
Pac-Man.
Pac-Man.
And then the little triangle.
Oh.
Where those
Stick dude. Yeah. And to be honest, they were little triangles, but we just draw real quick, you know. Now there's one more symbol.
Just minus.
Yeah, the minus, right, which you can use if you want to. So if you got to do 59, you could do 6 Pac-Man minus 1, or you can just do 5 Pac-Man and 9 sticks. Right, it's up to you. Now they did invent a placeholder for 0 kind of idea, but they didn't see it as a 0. It's really weird. So, yeah.
Like an empty space.
Empty space. They just wanted to signify an empty space more clearly. They didn't see it as having its own meaning,
Oh, wait, on the front.
which is interesting.
And then there's civilization flag.
Yeah. There, I mean, I've read places that supposedly they had developed the idea of 0 more directly, and then there's civilization flag. So,
I was reading this thing about this old path in the Amazon they discovered. It pretty much goes from the Atlantic side to the Pacific side, and it's like along one of the biggest parts of the continent. And the mile, it's not mile markers, but it's like the distance markers. So it'd be like I think one was like a tapir, a tapir, That's like, oh, you walk like tapir. It's like how much a tapir would walk in a day, or
Oh,
something like that.
cool.
But it was, but the crazy thing was, it wasn't only one of the tribes. Like they all shared it. They all understood these like measurements that are all like
I see.
very
That's beautiful.
animist. Yeah.
See, that's kind of like the next step above just numeration systems is, I mean, we used to base our measurement system on measurements of the King of England. And now, for example, real quick, do you guys know how we officially measure a second?
It's like light traveling. No, not anymore.
Well, yeah, it could be do that, but it's cesium atoms. How long it takes for a certain insane number of times for it to go from its excited state back to its ground state. It's kind of, so when they say atomic clock, cesium atom is what the atomic clock is based on. It's yeah. That's why we call it an atomic clock. Yeah, it's crazy. It's not that it's powered by some crazy atomic power. No. Yeah.
So it's like more accurate. Right?
Yeah, it's insanely accurate. Yeah, as long as nothing fundamentally changes the properties of cesium atoms, in which case everything changed. So who cares? Sorry, that was a little much.
There was someone, I think it was a comedian, making like horsepower. It's like 3,000 horsepower. It's like, where would you be like have 3,000 horses like pulling something, you know? That's like, we gotta move it up.
No, you got 300 horses, each have the strength of 10. So,
yeah,
right? It's still hard to get 300 horses on your cart.
Might have been an old Seinfeld now, I think.
Huh?
Might have been like an old Seinfeld. No.
Probably. Yes.
I have a homework question. 8.2a. It's the 35. It says prove or disprove that the square of any whole number is a multiple of 3 or one more than a multiple of 3.
Alright, hold on.
Okay.
8.2, 35.
35. Yeah.
The square of any whole number is a multiple of 3 or one more than a multiple of 3. Ooh, that's a good one.
Yeah.
So you kind of start yourself out with the whole number
Yeah.
squared, and it's either a multiple of 3 or it's one more than a multiple of 3.
Yeah.
Okay, so, all right. Do you everybody hear this problem? This is interesting. It's number 35 and 8.2. A. The square of a whole number is a multiple of 3 or one more than a multiple of 3. That is tripadel. So let's try it out, right? The first thing I do before I try to start proving this is to just start doing some examples, because maybe I'll see something from some examples that'll help me figure out how to prove it. So 0 squared is 0, which is 3 times 0, yay. 1 squared is 1, which is 3 times 0 plus 1. So this will be 3 times 0, check. This is 3 times 0 plus 1, check. That's 2 squared. 4, which is 3 times 1 plus 1, check. Right? Yes?
What problem is this?
This is 35 in 8.2.
What is this one?
A. So let's see real quick. 3 squared is 9, which is 3 times 3. Check. Right. So far I don't see, I might have to do a few more, see if I see anything. Does anyone, probably, you guys haven't tried this yet. But one thing you could try, for example, is it doesn't seem to necessarily have a difference if they're odd or even, right?
I don't think so.
Doesn't look like it,
No,
right?
because 4 squared and 5 squared both are the same. If
Yeah,
they're
so
plus
4 squared, 16, which is
50
3
plus 1.
times 5 plus 1.
And then 15 is, or 5 squared is 25.
So
which is-
maybe-
so.
5 squared is 25, which is one more than, yeah, so it
3
doesn't,
times 8,
yeah,
so it doesn't.
it ends up not
I don't-
having that.
Yeah.
So, I mean, what else could you do? You really should, so what this boils down to is, it's impossible for n squared to be 2 more than a multiple of 3. That's really what this is saying. It's either a multiple of 3, 1 more than a multiple of 3, but it can't be 2 more than a multiple of 3. And that's kind of freaky. Okay. I'm not going to spend any more time on that, even though I haven't really given you anything to work with, but let me see, what kind of a hint can I give you? Well, think about it. I don't think you've thought about this yet, right?
No.
That's what that means. It means, right, listen guys, a number can either be a multiple of 3 like 15, 1 more than a multiple of 3 like 16, or 2 more than a multiple of 3 like 17. So why can't it be 3 more than a multiple of 3? Why wouldn't that make any sense? Because then it would be a multiple of 3. So it's 3 times a number, 3 times a number plus 1, 3 times a number plus 2, and then it rolls over. So this effectively is saying you cannot square any number and have it be 2 more than a multiple of 3, which is a neat thing. Sorry, this is as much as I'm going to say. So don't let that problem drive you insane. Try to think about it, but don't focus too much time on it. It's just an interesting side note, really.
Like a lot of those exercises are like trippy, and then the answer is like you're like what?
Yeah, I don't know. What
even
is
get
this?
there.
What does this one say? I'm curious now.
Yeah.
Let's see. Yeah, don't forget that A answers are in the back. Some of you guys know that all too well, but some of you guys appear not to know that.
Even the answer that was in there was like, I didn't.
35. True.
Oh, okay.
Ah, there you go. It actually tells you exactly what to do. So
Confused.
that's pretty much, it tells you exactly what to try to do.
Yeah.
So what did we just say? Every number can be represented, every number, just number, can be represented as 3m, 3m plus 1, or 3m plus 2. Right? So this number is either this, or that. So you just square each one of those and show that none of them come out to be in that form. Yeah, that's the trick.
I don't get number 8.
What's up, Dustin?
I'm looking at number 8, and it says if A is an even number and 7, isn't that divide?
Good. 7 divides A, so 7 goes into A.
And A is an even number?
Say again?
And A is an even number?
Yeah.
So it'd be like 28.
Yeah. Isn't 28 even?
Yeah.
Doesn't 7 go in?
Yeah.
Yes. So, but I love what you just did. I love how you were like, what the shit's wrong with you, Jeff? But you didn't really mean that. But what you really just did was, what's the only way that could work? Because off the top of your head, like, multiple 7 being even. But of course, if I multiply 7 by an even number. So, this isn't exactly how to do this problem, but think about it. A itself, if it's even, it must be divisible by 2.
Yeah.
And I also tell you, it's divisible by 7. What's the only way both of those things can be true? So, watch this. Let's see. I need more room. So first thing I tell you is A is even, correct?
Yep.
So we know, help me out here. If A is even, oh, you're the dead, are you? Or are you both dead? Both are dead. If A is even, what can I write about that? What can I write? What's one thing I could, A is even, so big deal. What is that? How can I write A then? Or, yeah. Well, what's the main thing about A being even?
Is that it's divisible by 2?
Which means it's a multiple of 2. Which means I could write it like this. Right?
Okay.
Okay. And then they tell me that 7 divides A, right? Okay. So that means that 7 divides 2m. Because A is 2m, right? So, can 7 divide 2? So if 7 divides 2m, what has to be a factor of m? 7. If 7 goes into twice something, doesn't that something have to have 7 in it?
Yeah.
Because 2 can't do shit for me, right? I really want this to make sense. This is a different way than I explained it on the answer key, but 7 goes into an even number. This piece of the number must have, M must have a 7 in it.
Yeah.
Therefore, this must have a factor of 14, 2 times 7. Yeah, that's one way to do it. I would accept kind of talking it out also, right? But the really big thing is, all right, so I just did 7 times 2 there, right?
Yeah.
But that doesn't always work. 2 goes into, let's see. If 2 goes into a number, and 4 goes into the number, does 8 go into the number? No, right? So, for example, does 4 go into 20?
Yes.
Does 2 go into 20? Does 8 go into 20? Nope. And what's different is these share a factor of 2. I really want this, so 2 and 7 don't. So anything that doesn't share a factor, I could have written this problem using those numbers. I could have written the same problem with 3 and 11. I could have written, I really want this to make sense. In fact, here's how it connects to fractions. And Destiny's like, good Lord, man, ask one question. So just do not. The only time that the LCD will be this times this is if they don't share any factors. If they share factors, the LCD will be lower. That's actually connected to the idea we just had. So if I put this and this, what's the LCD? 14, right? But if I put this and this, what's the LCD? 4. Not 8. 4. Because they share a factor of 2. So one of them already has a factor that it doesn't need more.
Yeah.
I really want that to make sense. Okay. So that's why these kind of numbers make fractions, adding and subtracting easy as shit. Because if they don't share anything, they need each other. Right? And it makes that kind of problem possible if I have things that, again, does anyone remember what I called numbers that don't share a factor between them? Relatively prime. Because, for example, is 9 prime?
Yeah.
Is 9 prime?
Oh.
Why is it not prime?
Because it's multiplied by something.
Because 9 can be broken into more than just 1 and 9. Yes? But 9 is relatively prime with 17. Because they both don't share a factor. Except one, which we don't count. Yeah. One doesn't do anything for me with fractions and stuff here. All right.
Yep, there was a homework about that.
Way more than you wanted. Huh?
There was a homework, like an exercise in the homework that showed show how many factors there are. Or like do a list, and so list out the factors. So it'd be at the end there was like, how many factors do prime numbers have? So it'd be 2. And then you see all the other ones that are, even or the odds.
Oh, okay.
I don't remember, I think it was in number 5 or 4.
Gotcha.
Something like that.
Okay. I'm not going to give you the key quite yet. I have the answer key. We'll hold on to it for a bit.
Bookstore closed at noon?
I have no idea. I'm sorry.
Yeah, it is.
Yeah.
It does? Closes at 1?
Yeah.
What the shit's that about? What? Does it close at 1 every day?
Yeah.
What the hell?
It used to be 2.
My God. Okay, sorry.
Yeah.
I mean, back in the day, we had Math Study Center tutoring on Saturdays. Now we don't even have it on Friday. Now we don't even have it after 3. I mean, because the Tech Mall shuts down at 4. It's insane. Anyway,
Yeah, everything closes it.
yeah, Tech Mall shuts down at 4. And it doesn't open until 9. So people that have 8 a.m. classes that need to print a paper out, well, that's too bad for you. Sorry, my gross smut administrator overlords.
Do they go through the videos you post?
Sure they do. I know they do. Hey, Dean. How you doing? Yes.
Can we go over like a Mayan?
Yeah.
I know how to do it. I got the right answer.
Okay.
I forgot how to do it.
Oh, so you knew for sure at one point, and now you're like, I'm not sure how I do.
I had the answer on my previous test.
Okay,
I
gotcha.
knew how to do it, I just-
So guys, help me out, remind me what tell me anything about the Mayan numeration system. Anything.
It's vertical.
Oh, it's vertical, okay.
Yeah.
I'm sorry, I thought you said it's radical.
I mean, it can be.
Dude.
It has 0,
Yeah, so it's vertical, so what are the places? You guys remember?
1, 20.
18.
360, right? Because and again, why did they do that? Because a year is roughly 360 days, so they wanted, and that's important. Yeah.
Yeah.
So, and then forever after that, it's like a base 20.
Yeah.
But this is not a base 20 because they did that one little weird thing, right? But they can do whatever the shit they want to. Right? We all made this shit up. What are the numerals? One was
Dot, little pebble,
little blueberry,
5, pancake,
pancake, and that's it. And then of course they have
the 0,
0, which I think this book drew differently than I did. I can't remember how this book did it.
loaf.
Well, I just do it like this, I think, but they had some, I think they had like little lines in there.
Yeah.
Okay. Again, can't remember if I don't know if I made a problem where you need 0, but yeah. So you need to know the symbols, and I would accept something approximating, a loaf of bread, right? Okay. And then of course, I really want you guys to understand, if you look back at this stuff, the work we did between bases, using our symbols, right? Base 5, base 7, whatever, is the exact same work we do with different cultures with different symbols, right? Is this enough, or
You got an example.
yeah, so let's say I've got the number, what do you got, Jack? 511. And I wanna know what that is in Mayan. First off, have I gone far enough?
Yes.
Definitely, because the next one will be 20 times that, 7,200 is too big. So remember, you always try to think one more step beyond what you got, just to make sure you went far enough, right? All right, so now that I know I've gone far enough, what do I do now?
Start with the higher.
Biggest, 11. Because I want to see 511. How much can 360 take care of this? Well, how many 360s are in 511?
1.
One time, right? So this will be 1. And what's left over?
What is it?
151. So now so I really want it to make sense. We have 511. I have to take care of that. I have to have all of my places take as much of that in as they can. So this guy, one of these guys takes care of 360. How much do I have left? 151. How many of these guys then can help me? 20 goes into 151.
1, 7.
7.
Okay.
So, let's see, so 151 divided by 20 is about 7. So how do I make a 7?
Pancake,
1 pancake,
2 blueberries.
2 blueberries. And again, any Mayans out there, I'm, yeah. And what's the remainder now?
11.
So 7 times 20 is 140, so there's a remainder of 11. Is everybody cool with that? And then the ones can just do 11 blueberry, or 11, so how would I do 11? Not blueberries,
Double stack.
but I'd have, yeah, good. Double stack
And one
with
blueberry.
1 blueberry,
Yeah.
11. No whipped cream, no syrup.
For the explanations, should we just go all in? I mean, when,
Like which one?
for like number 7.
Yeah.
Or number 6, like stuff we have to write out,
Oh, well, 7 you just have to,
reasons.
7 you just have to show me how it fits into the rule, right? 6, yeah.
But like, how much do we have to show you? That's the thing.
When in doubt, go a little more.
Okay. Yeah.
I mean, it's almost impossible to say too much. Now, if you say everything great and then your next sentence is wrong, that kind of sucks. You should have held back, but I can't do anything about that. Most of the mistakes I get from people is they didn't say enough. So that should be
Yeah.
a big clue.
So for example, if you're like, have 23,412 is divisible by which, or show it's divisible by this, and we'd be like, this number, well, these are reasons. This number, these are reasons. This
Yeah,
number,
yeah, yeah. So for 6, you just say it's even, and show that 3 goes in, because when you add it, it's a multiple of 3. Then.
Okay.
So you just have to do it and then say it. Do it and then say it, right?
Okay, very good.
Yes.
Is it possible for me to leave early? I have to take my grandpa to the eye doctor.
No matter what the reason is, you can always leave whenever you want to.
Thank you. I'll do the answer key.
Oh yeah.
Sorry, I got it.
Oh, and here. Ryan.
See you.
Thank you.
Next week.
Yes, see you next week.
Oh, that's next Thursday, dude.
No, yeah, next week. The only next week. This is the last week of classes. Next week is just finals. So you don't come to any normal classes, just your final. Yeah.
But then, if you get the other brain, totally would forget that. Yeah, and still comes back.
I always have some email in there saying, "I'm here. Where's everybody?" I'm sorry. Don't be there anymore. You're fine.
Alright, man. Take care. You
too.
Alright, man. Take care.
And then there were 6. Or 7, I guess, Mason stuff.
Yeah.
Oh, I must have missed when you did number 9 with subtraction. And I got that you subtracted
Yes.
300 from 540, you got 240, and then you put in parentheses. Is that the answer, 240?
No.
Or do you just
All right.
do
So if I ask you, let me ask you this. You ready? What's the GCF of 7 and 21? GCF. GCF means the biggest number that goes into both. So what's the GCF of 7 and 21? 7. So your answer has to be a number, right? So the subtraction, 7 and 21 is an easy ass question, yes? Freaking easy. When I get bigger and bigger numbers, that gets harder and harder to think about. So subtraction uses the idea that if they share a multiple, they must be in the list of multiples of that. I really want this to make sense.
Do you have to keep track of how many times you subtract?
Until you get to a point where it's easy to tell, like 7 and 21, right?
Right. So do you just go back and forth?
So when you subtract them, you replace the bigger number with your answer. So you got 240, comma 300, right?
Yeah.
Now do 300 minus 240 is 60. You replace 300 with 60.
Oh, okay.
Right?
Yeah.
And then do it again if you need to. But if you get to a point where you're like, oh, I can see the GCF, then you're done.
Okay.
Yeah.
Oh, 9. There you go. So the way I did it was just 25 instead of had the fraction. Then that we have. So 25 times this divided by like the original distance. But then yeah. That and then because you did mention it, make this one as a fraction.
Oh yeah. So I didn't take points on, but in general, if the problem starts with fractions, it should end with fractions.
So it would be 1 57 hundredths.
No, because that's an approximation.
Okay.
So right here, this is 5.5 divided by 3.5. Can't you double the top and bottom? Yeah.
Got it. Yes.
Cool.
So you were just saying that these, like if I make them with this one 11, this one 7 instead.
Yeah, because I got 11 over 7 over that combination.
11 over 7 would be the answer
Yeah.
as a fraction. Yeah.
Yep.
I would do this.
All right, I'm gonna go ahead and give you this answer key.
Yeah, because I wrote like how it was. Instead of putting it in, they like, sure.
What did you do?
Can you remind you guys if
11.
if you haven't tried to practice final out,
Oh.
don't just get this out and look at it and agree with it, right? Sit there and go, oh yeah, I would have done that. Because that'll build false confidence.
Question.
Yes.
For number 10, I got, I just didn't
Or I guess
multiply
that would
it
be
out.
fine.
You always
But I
want
didn't get it right.
the
Like I
number.
did.
Like
Oh.
I got
I did 1 too short.
2 cubed times 3 squared times 5,
Okay.
which is the answer.
So
but
technically you're right,
Okay.
but normally we want to say, you know, because if I said, how old are you? And somebody said, oh, 3 squared times 5.
Technically.
Interesting. Yes. Totally, right? So tests and quizzes, for example, real quick, tests and quizzes, you could get some points back, even quiz 1. Depending on what it was and what you did, and if they get it right, you could get some points back. Not as much as you would have. Homework corrections are not late at all. No homework corrections late because they're due the day of the final. Yeah, so it's crazy. Say again? Yeah, even late homework that you've never turned in, give it to me. You'll get more than 0 for sure. Yeah, and the reason, I mean, you'll get, you know, because final's going to be cumulative, so it's going to cover everything. So anything you do is going to help you get ready. So yeah. Mason, you're right.
Yeah, it's funny.
Oh, these Christmas lights. How far away do you live? 4 squared times 7 minus 11. I mean, of course, the funny thing is, I actually tell people I'm 7 squared years old right now. Because it's neat. I've become a square again.
Mr. Waller?
Yeah.
For number 11, the practice test, is that page 82 from the book?
Yes.
Okay, alright.
And it's just a series of things that are in Rome and Babylonian that you have to convert back.
Oh.
I was just being lazy. I didn't want to take pictures and cut them and paste them and put them on. It's just like, load the book, do it.
The one day I forgot the book. Like, it wasn't enough.
For 14, I'm just having issues reading the first sentence. Are you saying that 3/5 of the cookie recipe makes enough for each kid to get 1
A
cookie?
recipe for cookies. Will it make enough for the whole class? The recipe as it is, will it make enough for the whole class?
Yes.
How much does it make? It makes enough for how many people?
Oh,
3/5 of them. So you could actually take a second and figure out how many students a recipe will make, how many people a recipe makes enough for, right?
Yeah.
If it makes 3/5 of the students, that would be 3/5 of 45. So, and that could be one method you use to solve this, right? If you know what to do with that number.
I have a question.
Yeah.
I don't know if I did, but
I could have made a mistake. It's easy enough.
45. I got, it was 3. You got 3 times 3 times 3 times 5.
Well, that's a neat one, Jeff.
Like I had it.
Okay.
You got one too many threes there.
Okay, so it would be divided by 3.
Yeah,
I'll get back.
that's better.
Okay.
But that's the way that I saw it. Like,
Yeah.
Oh, man.
So I'm still averaging about an A- on my
divided.
answer keys. Which one was that, Mason?
Number 10.
Oh, yeah.
10.
So it'll be 27.
45 and what was it?
45 and 120.
120. So for some reason, I decided to put 3 times 3. So I was trying to be all clever and neat and say, I'm gonna do this in my head. So I did 9 times 5, but I saw the 3 and put a 15 here. So I have 1 too many 3s. Yeah, I have 1 too many 3s. So do you guys see this? Right? So this is a mistake I made on the key. It should only be 3 times 3 times 5.
Oh, okay.
Okay, and that's my mistake for trying to skip steps. So the result should have 2 3s, a 5, and 3 2s. Right, which I think Mason said is 360.
Yeah.
Nifty. So that just shows you I do not use test banks to create things.
Will we have to do any long division?
Oh, possible, yeah.
Possible?
You haven't made it?
Huh?
You haven't made it?
No, not really. I have a thing I can work from, but like from last semester, but I'm gonna change a little bit, so. And I can't remember what it was on, so.
You got a
Yes.
cross up.
You know the question's gonna be?
Alright, so normally my finals are in the 20s, like 25 questions or something, right? And that's counting A through whatever, yes? Okay, so it won't be 25 questions and each one is A through J or something. Right? Should be roughly 25 or something around there. But just to ask you guys, how long do we have for a normal test?
Like 2 hours.
Well, 12:30 to 2:10, right? So an hour and 40 minutes. So we get like a whole 20 more minutes for the final. So can the final really be that much longer than a normal test? Not much, yeah. Does that make sense?
Yeah.
So it'll just be like a smidge longer than a normal test. There will be bonus on the final. It will be possible that like you can make a 106 on the final. That is possible. But you can't make a negative on the final, so. Careful.
That's cool.
I'm like, you spelled his name wrong. Negative 10.
Like, there's 2 JCs. Which one's which?
Exactly. Yes.
I had a question on,
Yes.
So I started, I don't know, like,
Reading fifth for 30, all right, and then 45, okay. Well, why is this 4?
I think I need to put, I was looking at this one, so I think I need to put,
45.
yeah.
Yeah. So there's a few different ways you can do this. So you got, here, the problem with what you did here is that is 16 fifths. And then you have to also, well, wait a minute, I see what you did. Oh, I see, I'm with you. Okay, this is beautiful. So you brought the 30 up there, I love it. And then that should be a 45, right? Because the 45 would come up. And then you just keep going like you are and you'll be fine. I love it. Keep going like you are, yeah. So you can reduce this, you can probably reduce this. Wait. Yeah. I love it. Okay. And eventually, you're gonna have to divide by that 30, right?
Yeah.
But I wouldn't worry about that yet. I simplify that one side, yeah. Oh wait, actually one thing, that's what's trouble. This is what it is. Oh, when you multiply this up, somehow this became 1630, it's supposed to be 16 fifths. So I think that got in your brain. That goes up, it's gone.
Okay.
And then this is 16 fifths, okay. So this shouldn't be, yeah.
So it should be 16 fifths.
Because you changed the top to a mixed number.
Yeah.
And then the 30 on the bottom goes up to the other side. It's not even there anymore. So it's, yeah, okay.
Sorry, for this one, said it was, this one would be, say 340,
Sure.
and then 110.
Yep.
Okay. So then this, would it be
So
three
you need-
separate?
You need 2 3s.
Uh-huh.
Bam.
Okay.
He doesn't give me any more information because I've already got a 3. I've already got that 3 covered. Yeah.
Got
Need a
it.
5, so he's covered. And then, I need
And then
3
those
2s, and I
are-
haven't put any 2s yet. Yeah.
So pretty much it's like,
So what I normally do is I write down one of them, and then I kind of take, okay, what have I not written yet that this guy tells me?
okay,
3, oh, I got it. 5, oh, I got it. 2's, oh shit.
cool.
Yeah.
Okay.
That way you don't repeat factors.
Yeah, cause I was like, it's, like, it gave me like 5,400 or something.
Oh, I see.
Wrong.
Well, you know, I couldn't even do it, so it's all right.
Seen the Doctor Strange?
The what now?
Doctor Strange?
Who? Oh, Doctor Strange, not yet, no.
Damn.
It's been a little busy.
Ah, I get it.
Yeah. So I wanna watch the Batman, because somebody told me that was actually
That's,
like a true,
Yeah.
nobody's ever gotten the character right.
yeah.
Oh, yeah.
And of course, Doctor Strange, I do
People
wanna see
crazy
it.
over the Batman. They say
I sort of was like, I don't wanna watch it, I don't wanna watch it, and now enough of my friends have said, you know, it's actually a good job, it's actually a good job. Cause you get tired, it's like, oh, freaking Batman. Who else is gonna freaking play Batman? You're like, you're not really an actor unless you play Batman.
Yeah.
That's gonna be,
I don't
Tom
know.
Hanks' reprising role.
I love it.
It's gonna be like
Tom
the
Hanks.
old Batman.
Oh man, yeah, he could be like the, what was the cartoon, like the
Batman
Batman
Beyond?
Beyond?
Uh-huh.
Yeah, you
Yeah.
could be the mentor Batman for the,
And there's other, they did, where it's like, he's like, Batman's been retired like 10 years, I think, and then he's just like, screw it, I'm coming back.
oh, I see, yeah.
Yeah.
Well, there's that, and then you got Flashpoint Paradox, where it's,
Oh, yeah.
Bruce Wayne, they got killed, and it's the dad that becomes Batman, so he's old, he's like, anyway, enough, geeking out over comics, sorry. Sorry, people that don't care about comics.
Our normal, office hours tomorrow?
Yeah, this week is all normal, and then next week is
The ones on the sheet.
here. And of course, Monday's a holiday, so,
What's on Monday?
huh?
What's on Monday?
Memorial Day, yeah.
Oh, Memorial.
Just in time to give you a little more time to study
That's cool.
as you honor those who have fallen.
So veterans is for living, and then Memorial is for passed away. Okay, I get it. I'm getting the hang of it.
Did I say that one year, I got, there's a teacher appreciation day,
Oh, really?
like a teacher's day. There's one in the US, but there's one in, I think, out of a Korean student, and there's a Korean teacher appreciation day. So she brought me a belt. And what's really funny is it fit perfectly, and I needed a new belt. I'm like,
Wow.
how did she know? Because I'm always wearing, you never see my
Yeah.
belt. But anyway, so I thought, ooh, I'm gonna make out now with the freaking Korean Teacher Appreciation Day and the United States Teacher Appreciation Day and who knows what other. And that was the last time I got it.
Oh, dang.
What day is it normally, or a US one?
I have no idea.
Oh.
No idea, because, I mean, nothing's ever happened on that day since then, so it's gone out of my head.
It's called the summer vacation.
Oh, yeah. Well, you know, most of us still work over that.
So on this one, it's easier, but I don't know if I.
Well, let's see, let's look at yours. So you got this, you changed that, we'll tie that up. Yeah, keep going,
That's mine, and then
keep going, you're fine.
I was just confused here, cause I don't know like where the 15 came from. This is the practice one though.
Yeah, right here, when you divide it by 4, there was a 4 down there already. So it made 16. So like right here, if you were to divide by 30 right now, it would make 150 on the bottom. Because there's already a 5 down there. So there was a 4 on the bottom, we divided by 4, 16 on the bottom. But we didn't do that,
Yeah.
so that's why it's not the same. The steps aren't set, by the way.
Yeah.
So you don't have to have them happen the same way. So that equals 30x, right? Good, and then you're one step away, divide by 30, reduce that, and you're golden. Yeah. You're welcome.
See, I don't know if everybody got these. My horrible writing. All right, and it starts at 11:35. You better be here.